So thank you very much. Thank you for the invitation. Also thank you for the kind introduction. What I would like to show you now is sorry, as long as my voice lets me. What I'm showing you now is a potential path towards Sustainable Development Goal 7. That is dealing with clean and affordable energy. And we all know that we have targets, we have indicators, and the story behind it is rather simple. It is that we should save energy, we should be more energy efficient, we should turn to renewable energies, and that we should have also global partnerships on research and investments and so on in this field. As is also shown on this slide, it's the same story about what is SDG 7. And the question is now, how do we do that? And we have different approaches to that. We have different disciplines bringing in their different knowledge bases. And what we were looking at this issue is, what could you contribute as a spatial planner, as an urban and regional planner, who is working on the question of how infrastructures, houses, companies, and so on should be distributed in space, and where to find the ideal locations for different issues. What I would like to show you now is the approach, the general approach to integrated spatial and energy planning, as we have drafted it, and mainly at our institute, also in governmental working groups, and this is also an issue where we have now also governmental decisions on it. And the main thing about integrated spatial and energy planning is that there is a recognition that spatial development has something to do with energy consumption. It's very plain, very simple, but there are dimensions of the energy demand, spatial dimensions of energy demand, and there are spatial dimensions of energy supply, and we have to consider them in drafting our spatial plans, not only spatial policies, but also the spatial plans on the provincial, the regional, and the local level. We have, of course, written books on it, and the yellow thing here is very interesting. It's a paper series by the Austrian Conference on Spatial Planning. That is a body, it's an organization that coordinates spatial planning activities between the federal state, the province, the state, the federal states, and municipalities, cities, and so on in Austria. And I was accompanying, scientifically consulting a working group that defines the idea of integrated spatial and energy planning as part of spatial planning. So what are the spatial dimensions now? In the energy supply, when we look at the energy demand, there is something like energy efficiency of spatial structures as a refrigerator or whatever would also have a kind of energy efficiency based on the components the technical device has. And in the same thinking, we are approaching spatial structures that have components like, for instance, residential areas, commercial areas, industrial areas, and so on. What is an energy efficient spatial structure? It's one, and for spatial planners, this is a very familiar terminology. It's mixed-use areas, it's something that deals with density or moderate density, depending on the spatial archetype you are in. If you are in an urban area, rural area, of course you have a different perception of density. It's about compactness of settlement structures, of nearness, so that you can maybe also have walkable and bikeable settlement structures. This is very important, and that saves energy. This is nothing new, of course. That's something we already know for 40 years. Much in the sustainability debate is known for 30, 40 years, but it's still not put into operation. And this is the problem, not to know these issues, but to put them into operation. And that's what I'm talking about. And then we have a spatial dimension of the energy supply. And this has to do with the securing of sites for all kinds of energy facilities, a power plant, a cable line, whatever needs locations, need sites, and you have to secure them. It's about the securing of resources. And I would say this is a rather new idea of the energy turn and the energy transition. What does it do in space? Because what we are now doing, if you talk in an ecological footprint language, most of our energy supply is based on borrowed land from the past. That means fossil energy that was transferred, or biological productive land that was transferred into fossil energy under conditions that are no longer available in this planet. And now we are able to dig this out, use this resource. But if we take the energy transition serious, we have to stop using this resource, which means we are no longer able to borrow land from the past. We have to integrate it in the present land uses and land use matrices. And this is something that is actually new in the energy transition. And then, of course, this will cause land use conflicts, and we have to deal with them, and we have to mitigate them. And finally, we have found out that these efficient or energy efficient spatial structures are not only energy efficient, but it's easier and more economically feasible and technically feasible to have grid-bound energy supplies in these kind of energy efficient spatial structures. So what we are targeting also with the ideas to implement this issue in spatial planning in Austria is to deal at the moment mainly with these energy efficient spatial structures. Of course, we know that we have to take care of where the renewable energy is produced, take care of wind power plant sites, and so on and so on. But this is a very important also issue to combine the spatial dimensions of the energy demand and the energy supply. And this is also, by the way, these are the places where the people live. And this is also very important. And of course, just want to show that with this slide that shows urban areas, small towns and rural areas in Austria. It's very clear that in these spatial archetypes we have very different possibilities and potentials to design the energy transition. Urban areas, when you look at what is energy efficient, compactness, mix of functions, density, nearness, and so on, these are mainly assets of urban areas. So we have huge energy efficiency potentials there, but the limited potential to produce renewable resources there. That's the one thing. In the rural areas, we may not have that much energy efficiency potentials and gains in energy savings, but we will have the renewable resource base there. And so that means that we have to define certain interlinkages between urban areas, rural areas, suburban areas, and so on. And we have to make use of the conditions in these areas in order to design the energy transition. And what we are doing, and this is now an example, in the province of Styria, so maybe some of you have been or know Graz. Graz is the provincial capital of Styria. Is one of the major provinces in Austria when it comes to area, size of in square kilometers, if you want, and also, yeah, about 20% of the Austrian population might live there, a bit less maybe. And it consists of 287 municipalities. If we look at the map before, it would be somewhere around here, and this is Graz. So this is where I'm talking about now. And what is the idea behind the program that the province of Styria has now developed, and we have actually advised them and consulted them in doing so from a science base, is that they wanted to roll out the program of integrated spatial and energy planning for the whole province, for all municipalities, and they we combined different issues together and developed that and combined that. The one thing is the creation of a database. We have heard a lot about data now. If you want to make a consistent policy in a certain area, you need a consistent database. That's the first thing. Then I would like to show you, and I will show you a bit of the methodology behind it now, about priority areas for district heating, for grid-bound energy supplies, district heating, cooling, and so on. We will come to that later, why this is important in the energy transition. And we wanted to think about priority areas for energy saving and also for energy saving and environmentally friendly mobility, which is also healthy because it's mobility that you can cover on bike, walking, and also you combining that with public transport. And this is all possible in this energy efficient spatial structures I've shown you before. So the spatial structures that are based on mix of function, moderate or appropriate density for a spatial archetype, and nearness, compactness, and so on. So, first of all, I will show you a few things about the database. What we managed is to calculate the Austrian energy balance with a very sophisticated model down to the single building area. This is the first precondition to do that. And so we can calculate bottom up the energy balance as of a municipality, if you want. But by distributing the energy balance of Austria to the municipalities and to the built-up areas. This is important because when you calculate and add the energy balances of all municipalities, you will still get the Austrian energy balance. That's the first thing. It's something that is not guaranteed by bottom-up approaches. We have energy balances here. You see the share of, in a certain municipality, that's a rural municipality, of living, agriculture, industry, so very little industry share, service sector, and mobility. Then we would have another municipality with a high share of industry, of course. So you see that the municipalities, this really changes, the spatial patterns change the energy balance, and here we have Schladming, you might know that from skiing. There are always also downhill downhill races are in this area, and that means that although there is industry, the services, the tourism sector, and so on, have a high share in the overall energy balance of the municipality. We can also show the different fossil and renewable energy sources. In Austria, we have about 34% energy sources in the overall system, and this changes considerably between the municipalities, for instance, and also by purpose, from heating, cooling, process energy, mobility, and so on. We could even show different temperature levels, which is nice for the technical planners, but not for today. And of course, you can also make an energy balance for a whole province, showing the hotspots of the energy demand in the province, which is very nice. The question is, what do you do with that? And here it's very clear, the hotspots are the industrial municipalities, and a bit also the tourism oriented municipalities. What can you do with that? Of course, you can draft tailor-made policies, energy policies, but you can also work on that. There's a 250-meter raster in the GIS system. Work on that on the municipal level. This is a rural municipality again, and what you see here are the rasters with an energy supply, with an energy demand, which means there is a household, there is a farm or whatever in this cell. That's the first thing. Then we calculate an energy balance. It's the overall energy balance. We see this is the main village in the municipality with the highest energy share. We can design priority areas for district heat, and this is very important, as I will show later, in order to design the energy transition. In this case, We also know that the district area that we have identified is more or less covering a supply area of an existing biomass-based district heating system. So the question is, what is the value behind that when there is already a district heating system there? And there are two values, one that we expected, the second one we didn't expect. The expected one is, you have these blue areas here. These are the new development zones according to the spatial development strategy of the municipality. And you see there are some inside this area and some are outside. So if you want to make priorities for the settlement, for the development of new settlements, then that gets rather clear. That was the intended part. The unintended part was that the small company who runs the district heating system said, wonderful that you showed us this map, because now it's scientifically proven that I cannot connect each of these people outside the supply area. And this is not because I'm a bad person, it's because it's not economically feasible. So that's was also very nice. So I said something about mobility. What we have in Austria, we have a data set about the stops of public transport, and they are also classified in different classes depending on the amount of connections that you have and also the kind of transport means that you have. And what we did, we combined it with a model to see how big the intensity of use of the areas around these stops is. And in this way we also define areas for climate friendly and energy efficient transport, which means that are areas that can be connected or are connected to a transport grid and that are more walkable and more bikeable than other areas. And the interesting thing is, when you overlay that, and you overlay that with the potential settlement areas of the future, you can really see where it would be feasible and nice to support the energy transition and where not. And outside, it's not. Sometimes, also in sustainability, you have to draw a line and say, inside the line it's good and outside the line it's not good. And I think it's also very important to empower people to draw these lines. And of course, if you would think about what do you do with these lines, you would have a lot of ideas, or I would have a lot of ideas how to do that. For instance, you could connect it with policies like subsidy systems. Now what is very important as well is the question of coupling of infrastructure systems. And this is something we have already heard in your presentation in the morning, and it's something that we really need to make the energy transition, is to combine infrastructures, technologies, services, electricity, heat, cold, mobility, also to flexibilize the electricity demand over time. This is very important. Of course, we also have to integrate energy storage, but this is something that is not developed to market prices so far. So the first thing to do is to start with combined heat and power, to do something about power to heat, to cold, power to gas, to chemicals, and so on. This is actually from the Austrian energy strategy. It's rather new, was just adopted a few days ago, or a few weeks ago. And this is something of one idea of how we are doing that and also supporting that with spatial analysis. This is the use of wastewater energy. So you can, in the effluent of the wastewater treatment plant, you can extract energy via heat pumps, and then you could supply district heating systems, which has a clear spatial precondition. You would have to have users besides the wastewater treatment plants. It's very plain, very simple. And so what we did, we made an analysis of wastewater treatment plants in Austria, where they are located, and of course also which thermal loads you could expect. And we found out that actually this type, wastewater treatment plants within settlement structures, are 1/3 of all the wastewater treatment plants. And in this way we could combine, for instance, this power to heat, power to gas, power to heat and power to cold stuff, with an environmentally friendly resource. It's environmental energy in certain spatial contexts and with grid-bound energy systems. So this is also very important. And when you think about this rural places, you could also combine it with the food system. If you have greenhouse gas production from a heated with wastewater energy. At the moment, the ecological balance of greenhouse gas emission of greenhouse production of fruits and vegetables is not very favorable in Austria, because most of the glass houses are heated with natural gas. And if you have a different energy source, this would be very nice. The next step is to include spatio-temporal modeling, where we could not only search for spatial structures, but also to see at which times, in which space over a year, you could more or less make energy available, both electricity and thermal energy, and which potentials of coupling these energies would be possible. So, let me conclude that on the one hand, the challenges of the energy transition needs a spatial approach. Spatial analysis can really contribute to the design of renewable and sustainable energy systems, also resilient energy systems. And we have new development goals. And what I want to conclude with, even if you don't believe in climate action and the energy transition, you would still fulfill a lot more sustainable development goals by the approach of what is an energy efficient spatial structure. It's also a spatial structure where people walk and bike more. It's a more healthy structure. And we have more potentials to have efficient infrastructure systems, and also to have more sustainable communities, also when you think about the organization of how you could organize renewable energy supplies more as a bottom-up civil society issue than the issue of large-scale companies. So, thanks a lot.